Hey MMT followers, Christina Fuges with MoldMaking Technology, back for another MMT Chat. My guests today are Robert Graup, the Toolroom Manager for Intex Tooling, who is also a new MoldMaking Technology Editorial Advisory Board member, and Naithan Loach, who is Senior Product Manager with the Axiom Group. Both companies are based in Ontario, Canada, and are somewhat related, but we'll get into that later. But first, I want to say hello, gentlemen.
Good morning, Christina.
So, hey, Robert, Christina. Why don't you... Hi, Robert and Naithan. Robert, why don't you start off by giving us a snapshot of who Axiom and Intex are, just to give a snapshot of how the companies are separately and who they are together.
Oh, okay. Axiom Group is primarily an injection molder. Intex is a division of Axiom Group, which is the tool building division. We are primarily set up to service Axiom in the majority of projects, but we also service outside customers. And Axiom Group consists of 5 different companies. We have Axiom Plastics, the molding division where Naithan works at. We have APG Mexico, we have Intex Tooling, we have Smart Attend, and we have just opened up a new facility also in Ontario that is going to be a molding facility. In total, we have about 500 employees based across all of our groups of companies. We are automotive-based molding, but specialize in engineered solutions. So we're really not involved in shoot and ship product, more so providing technical support and design engineered solutions for the automotive industry.
Okay. Naithan, anything to add to that? Or did he do the picture?
Sums it up pretty well.
All right. So now let's get into the reason for this chat. And that is continuous fiber reinforced thermoplastics, composites or composites, and the impact on tooling. That's what kind of prompted me to schedule this chat, because I was talking to somebody in the industry, and this actually came up a few times, and I wanted to learn a little bit more about it. Naithan and I had a pretty decent chat about it, and I was not familiar with it. So I reached out to Robert, who directed me to Naithan. We talked. So now I think I want to share with everybody else out there. So Naithan, can you share with us who you are, what you do at Axiom, and then we'll get into the composite.
Yeah, so I'm the Senior Product Manager at Axiom Group, and I'm the lead for the crosslink composite technology, which is our name for it, essentially, or okay. CCT for short.
All right, so let's explain what that is. What is it and what is it used for? Continuous fiber, reinforced thermoplastics, composites.
Yeah, so our crosslink composite technology is particularly useful in helping plastics replace metals. Similar to reinforcing a plastic with a fiberglass or carbon fabric, but far more selective with far less waste, since we can put the composite exactly where we need it, and we don't have to trim it where we don't.
Uh-huh. All right. So you mentioned that you believe like we're at a tipping point, right? Where composite plastics are becoming mainstream even. Can you explain that a little bit?
Yes. So adding glass or carbon fiber to plastics is not new, but has long been limited to shorter long strands being added to the resin and the barrel during injection. The issue with this is that glass goes everywhere that you need it and everywhere that you don't. Designers are then forced to thin out wall stock where the strength isn't needed and then thicken it where it is. This makes for molding and tooling issues, and I'm sure Robert could go on for days about the problems we encounter with those. Not to mention the glass is chopped into pieces, so it loses a lot of its strength. We'll call these filled plastics, which is the commonplace. Every injection molder uses them now. There's currently a lot of applications where glass-filled plastics are in use and being reinforced by metal brackets where they need a little extra strength, or where the entire part is made of metal just because plastic wasn't quite strong enough.
Okay.
In most of these applications, we can add our crosslink composite technology to the plastic and target the exact locations where the strength is needed. Since we can keep the glass and carbon fiber in continuous length, like full length, we retain the exceptional tensile strength of the reinforcement and can add major strength to our design while utilizing the complex geometry that the injection molding is capable of.
That's interesting. So I assume that's why all of this is why Axiom has got involved in this technology. So, but what is it exactly that Axiom is developing with this crosslink composite technologies partnership?
So essentially there's several technologies currently in the marketplace that offer a composite.
Okay.
And typically what you'll do is you'll take a woven fiber and then you'll overmold it with plastic. The issue is that as soon as you try to add features like a hole or carry forces along an angle not parallel to the weave, you lose all the strength of the weave. So, for example, the hole creates a literal break in the fibers, so which damages its strength, and then non-parallel angle to the forces pull on the fabric and try and tear it apart rather than use the fabric to help it. So our technology, we can actually circle a hole. We can run a fiber in any direction, literally any direction. So if the stress is on a 37.85 degree angle, we can put a fiber on a 37.85 degree angle. Wow. We're not limited by 90s or 60, 30, 40. We can put it wherever we want. So that's kind of one of the key, I guess, differences that when we were looking through what was available on the market, we chose this partner and we saw some opportunity there and we decided to develop with them to make something better than everything that's in the industry.
And when you say, so there's a variety of these weaves, as you call them, right? So is crosslink, is that what you're developing with crosslink? It would be a variety of a weave.
Absolutely, yeah. So there's a few guys in the market right now that offer weaves. Usually it's like a 90 degree crosshatch, or there's one where they have a 60 degree. Those are fairly common. They're used not commonly in the industry, but they're used typically where we would want to be. The problem with them is they're very expensive. One, you can only buy them in a sheet format, so you're going to get, a 1 meter wide by whatever length you want. So if your part doesn't look like that, which literally no part in automotive is a flat, straight sheet, you're going to have to cut away whatever you don't use and you're going to waste it. So, which again, high waste, high cost, there's a lot of cost there. Whereas for us, we put it exactly where we want it. We don't have any of those losses.
Yep. It sounds a lot like the advantages of 3D printing, right? When you're instead of subtractive, you're adding material exactly how much you want and where you want it. Correct?
Exactly. And I'm glad you connected that dot because it's very similar. Really, we're 3D printing the fabric exactly where we want it, and then we're using the injection molded plastic to fill any of the gaps.
So is the 3D printing process a proprietary process?
There are portions of it that are. For us, the proprietary portion for us so far is that once you take the step further that, okay, yes, we can 3D print a fabric. How do you make sure that your ratio between fibers and polypropylene or whatever your resin is are consistent? Which is the first thing that any automaker is going to ask you is, how do I make sure that what I'm getting is exactly what I wanted and that I don't have fiber somewhere that I didn't want it? How do I make sure it stays that way? Our technology ensures that, or our patented technology ensures that you have a high level of quality and you can guarantee where those fibers are going to be in what ratios.
Okay.
Yeah. So really the patent is the quality side.
The patent is on the quality side.
Yeah.
Okay. So you talk about automotive. Are you primarily focused on the automotive market, or are there other applications and end markets that you're targeting?
There are other applications. Primarily automotive, I think mainly just because that's where our customers are. That's what we're comfortable with. But yeah, this technology is capable of far more than automotive, so we're definitely not going to limit ourselves.
Okay. All right. So since mold making is my thing, right? We have to talk tooling. So Robert, or I guess Naithan too, can you explain the implications of this continuous fiber reinforced plastic composites on mold tool design, on building, and even maintenance and repair?
Yeah, so I think I'll start first on that one, and I'll defer mostly to Robert. But from my side, the composite needs to be preheated so that it can be formed during the molding operation, and to ensure uniform adhesion between the overmolded resin and the composite. This preheated composite is very soft and pliable, kind of like a wet noodle. So when loading it into the injection molding tool, it's very soft, so it's hard to hold. So that's where Rob comes in, because it's hard to hold it, hard to keep it in place, and hard to make sure it doesn't move under injection pressure. So that's where I'll kick it over to Robert.
Okay.
I guess in general, a mold is a mold is a mold. So that the tooling can be quite simple, can be quite complex. It really gets an extra layer added into the tooling, no different than insert molding. Most of the time, though, insert molding, you're not trying to hold, for example, a lasagna noodle that's freshly cooked. We're holding steel inserts, or we're holding a previously molded plastic product, or some fiberglass sheet that's already been formed and treated, and we're over molding on that. I guess the complexity comes in on how you have to hold the shape and where you need to locate it in the mold. But in general, it becomes an engineering exercise more so than a tool building exercise.
So it's front end.
Front end, exactly.
So what are some things that a mold builder needs to understand in terms of that, if they were to get into this world, how it's different?
Well, I think as long as you have a really good, strong core of engineering, probably coupled with mold flow technology, because that's how we primarily do it. You're starting to look at how the plastic is flowing around whatever you're trying to encapsulate. It really is important. Like you said earlier, the upfront engineering, it needs to be done for this in order for the success to be there.
So you think the skills of Intex in general easily translated to getting into this world?
I think the blend of both companies, because both companies have strong engineering groups.
Okay.
It was really brought into the picture because one of our customers was failing, and we really started to push hard that we have a solution. Like usual, the customer didn't like the cost implication on the solution, but we did prove to them that this is the correct way to go. It really is the engineering and the mold flow technology, and then the experience of all of our engineers put together. No one room is stronger than one person. So
yeah, that's true. That's true. So is there a particular team? Is it just you and Naithan? Like, how do you two work on this, or are there different teams coming together?
Naithan?
Oh, man, you would think if it was just me and you, eh, buddy?
Yeah, it would. No, it'd be more successful.
Yeah, maybe.
Yeah, you never know. Sometimes more people can complicate things, right?
That's true too. Yeah, no, so on our side, we have a design team that's committed to this. We have a tooling group that a tooling design side that we have on our side. Obviously, Robert has his tooling design side as well. Initially we usually start with kind of Robert in a bit of a consultative role, advisory role rather, to say, hey, if you move this like this, it'll be easier for us to grab or hold. If you make these adjustments, then it'll make it easier for tooling down the road. So we'll support in as much as possible. Then once we start getting closer to actual tool build and tool design, then we kind of Robert takes more of a leadership role kind of on the project, really. So,
Okay.
yeah.
Okay. How many customers do you have for this right now?
Only a couple. It's a really new technology. We've we've only very recently developed it. We had one project which was extremely successful, and I wish I could put it into perspective. So assume you have an 8.5 by 11 sheet of paper. So that's a plate that we have on the bottom of a vehicle. That plate had to hold almost 3,000 pounds, which you can imagine for any plastic is absolutely insane. So and then the plate is, we'll say about 2 inches by 2 inches.
Okay.
So it's a tiny little plate, assuming somebody put a bottle jack or something like that under their vehicle, right where this plastic plate was, we'd have to hold it. And the result is we were capable of it. We held that plate. So, I mean, that's more than half the weight of your vehicle holding on this, sheet of paper plate that we made purely out of plastic with our
with the weave
crosslink composite design.
Yeah, that's crazy.
Yeah.
Out of curiosity, what was the time for? What was the lead time from when you got that project to? I mean, I know it's new, so I guess that would play into this. But how long was this? Did this take?
Yeah, so it was actually believe it or not, about a month and a half.
That's it?
Yeah, the tooling for the mold for the plastic plate had already been made, and they had overestimated the capability of the plastic with just a heavy glass fill in it. Okay. And it was failing majorly. So that essentially on the design side, our customer had underestimated it, and I guess didn't spend enough time with FEA. So they kind of came to us and said, this is failing, we need a solution. And, obviously Robert and I had this solution in our pocket. So we said, how about this? And so we quickly designed one up. Because it's similar to a 3D printing process, you can make parts pretty rapidly, not at high volume, but you get them out pretty quick. So we had some made up, overmolded them, did a few iterations of it, but by I think the third iteration, we were passing. So it was very quick and very successful. And now that we have that, it's kind of, okay, let's push it everywhere because it's obviously capable.
How exciting. Well, that's awesome. Thank you so much for sharing all that. So before I let you two go, I have to talk a little bit about COVID, particularly because Robert, you and I talked months ago, right, about Axiom, well, actually the whole group in terms of the face shields. So can you give a little update in terms of how that's going and actually how is business today?
Well, I guess when we did speak a few months ago, the project was at its infancy. Since then, we've built 10 plus injection molds. Production ramped up to a peak last month. We saw the orders now drop off but stabilize. And we've produced about a little more than 500,000 face shields already in a couple of months. It's not really the same type of face shield that you see out in the marketplace. It's a little bit more of a robust, reusable face shield as opposed to a throwaway item. And we just continue to produce that product. We have weekly releases that have been going through. And I think as far as I know, based on a conversation yesterday, we still have 2 months worth of projected releases. So it's going strong. It kept the lights on for Intex and Axiom.
Exactly. Well, and look what you were doing. What a wonderful thing you were doing, on top of that. So is it focused locally, or I know there was a URL, there's a website where people can purchase. Is it nationwide? Is it global? Where are these orders coming from and going?
I think primarily it's right now still in Canada. I did hear talks about having it put on Amazon Prime. So it would be coming, I guess, across North America that way.
Okay, cool. So my last question to both of you is related to COVID. I know you guys absolutely have learned a lot, even just through that project and having to respond and just kind of having to manage everything the past, 6-7 months. How do you see mold making in general kind of coming out of this or emerging in terms of what business will be like or how they'll run their businesses moving forward?
Well, I'm really not sure how to answer that. In my opinion, it hasn't even settled yet, so that it's still evolving. The whole industry it definitely will change. I know one thing that's here to stay. It is the web meeting.
Yeah, yes.
And I guess what Axiom has learned and realized that it is their strength that we were very flexible and we embraced change. We did it really without fear. Like it's a scary time. People didn't know what was going on. Literally from 1 week to the next, we went from having 400 people on the production floor across our facilities to having 10.
Yeah.
And that was all management. The production just stopped, and being flexible and being able to respond and bring new ideas to the marketplace is what kept us alive. I guess a Greek philosopher said change is the only constant in life. And
That's the truth.
We've learned how to embrace that, and that's what's made us successful.
I think flexibility has been the key for most people I've spoken to. Any additional thoughts, Naithan, about from your perspective?
No, yeah, I think it's made a lot of companies realize that working from home and flexible working schedules are far more possible. And I'm home because I have a sick kiddo right now. So, but it's far more possible than I think a lot of companies realize. And I think that's agreed with Robert. That's something that's here to stay.
I agree. Well, gentlemen, thank you for your time this morning. I think it's a wealth of information, especially on something that's new for you guys. I am looking forward to kind of checking back in to see where that whole world of composites goes for you guys. So keep in touch. Again, a thank you. And for everybody out there, for everything mold making, visit moldmakingtechnology.com. Stay safe and healthy, and stay informed and stay inspired.